Hi guys, welcome to the second screencast on the cardiovascular system. So what we're going to be looking at today during this screencast is just the responses. I realise it's got responses and adaptations up over. Your adaptations are going to come on a different screencast, okay? It's really important we understand the responses of the cardiovascular system to a single sport or just an exercise session. Now we should remember cardiovascular system is the blood vessels and the heart, okay? So it's all to do with the continual supply of nutrients and oxygen to support energy production during exercise, as well as removing carbon dioxide. So that's what we're going to be interested in during this kind of screencast, the responses to exercise. As soon as we start to exercise, what happens to our cardiovascular system? Right, okay, we're following the same protocol with regards to you're looking at the question, look at how many marks it's worth, you're circling important information, you're using your memory method, you're translating it and extending with an example. So, responses of the cardiovascular system to exercise. You've just started to run around. What do you think happens to the cardiovascular system? There's 5 things that happen. Can you see if you can just jot down 5 things? Pause it now. If you couldn't, here are some fill in the gaps. Hopefully you can get it from that. I think the 1, 2, 3, the first 3 definitely. The others you should be able to get. So if you pause it and give them a go. We've got anticipatory rise, increase in heart rate, increase in cardiac output. Those 2 are pretty much together, aren't they? Increase in blood pressure and redirection of blood flow. That redirection of blood flow is with regards to vasodilation and vasoconstriction. We're going to go on about that in more detail in a minute. So how are we going to remember that? So one thing I've come up to, you have to bear with me. You may not use it. You may think, yeah, this is going to help me. Responses of the cardiovascular system to exercise, all we need to do is change cardiovascular to cardio, and instead of vas with a V, just fat with PH, vascular, so cardiovascular, okay? And the only ones we're interested in are the ones in red, so the C-A-R-D-O, so cardio is just on its own, then F instead of V is PH, and then you got vascular at the end that you don't need to be worried about. And the C is cardiac output increases, A anticipatory rise, R redirection of blood flow, P blood pressure increases, H is heart rate increases. Use it if you want. If you don't want to, that's fine, but that's quite a decent, easy way to remember it. Cardiovascular responses. Okay, on the graph here, we're going to be talking about anticipatory rise and the increase in heart rate. They're 2 responses we get. Why do we get them? We're going to go through them in a minute. As you can see from the graph here, we've got this here is our anticipatory rise. Before exercise actually happens, we get an increase in heart rate. We need to know why that happens. And not only that, during exercise, right at the start of exercise, we get an even steeper rise. And again, we need to know why that happens. So if you could give it a go and fill in the blanks for me there with anticipatory rise, and the same for increased heart rate. So pause this and give that a go. Right, okay, so what you should have is anticipatory rise. So adrenal glands release adrenaline into the bloodstream. This stimulates the sympathetic nervous system to speed up heart rate prior to exercise. So what happens prior to exercise is we're standing on the start of that 100 metre block. All of a sudden, we know that our heart's beating quite quickly. That's because the adrenal glands have released adrenaline into the bloodstream. You should be okay with just saying adrenaline is released. This stimulates the sympathetic nervous system that speeds up our heart rate. We know now that sympathetic nervous system speeds up heart rate, parasympathetic nervous system reduces it. So before exercise, we get that anticipatory rise because we are adrenaline's been released into the bloodstream, it's been detected, sympathetic nervous system stimulated, speeds up our heart rate. So during exercise, that steep rise that occurs because our muscles are creating carbon dioxide. This carbon dioxide is detected, sorry I haven't got the chemoreceptors here, but carbon dioxide is detected by the chemoreceptors. This sends a message to our brain, and this stimulates the sympathetic nervous system to increase our heart rate further. Why are we increasing it further? We need to remove that carbon dioxide, and we need to get more oxygen on board. So that is exactly why we get an increase in heart rate. Following the increase in heart rate, we then also get an increase in cardiac output, don't we? And an increase in blood pressure and the redirection of blood flow as well. But with regards to those 2 key points, this is what you need to know. Okay, so what I want you to do is, could you pause this and answer this question, please, for me? Okay, we're going to go through the answer now. So what you should have is, before Garcia takes part in exercise, there'll be an anticipatory rise in his heart rate. This is because adrenaline is released, which has the effect of increasing the heart rate via sympathetic nervous system. This increases oxygen delivery to the muscles, or removes carbon dioxide. It's any appropriate answer there. That would be absolutely appropriate. So that's what you should have. It should have been pretty straightforward for you. That should have. Okay, another one. This was the one that was given out in January, just gone. So Fred is an open water swimmer. Fig 4 shows heart rate before, during and after a 10-minute training swim. Explain the changes to Freddie's heart rate before the swim. As you can see, this person has highlighted before because it's a key part of the actual text. And as you can see from before, you can see that his heart rate is level. Realise he's about to exercise. He gets that anticipatory rise. So can you answer that question for me, please? Okay, we're going to go through the answer now. Okay, his heart rate increases before the swim due to the anticipatory rise. This is where hormones such as adrenaline are released into the body to prepare for exercise. 2 marks, simple. Now this one didn't get 2 marks, it only got the 1. Freddie's heart has slowly started to increase due to anticipatory rise. There's your 1 mark. This happens because your body's preparing itself for some form of physical activity. No, we want more information. You need to know it's because adrenaline has been released, okay, which speeds up our heart rate. Okay, next question. Again, quite a lot of questions on this one. Joe has been taken part in a 6-week endurance training program to try to improve his 5,000 metre time. He used a heart rate monitor to record his heart rate during his first 5,000 metres. Explain using figure 5 how Joe's heart rate increases from the start of the race, from the start of the heart rate, according to 4 minutes, recording to 4 minutes into the race. So from here all the way to 4 minutes, explain what has happened. So before the race, and then during the race, what happens? Can you explain that to me? So pause it and give that a go. Answer: anticipatory rise of heart rate immediately prior to the race. This could be due to adrenaline being released, which stimulates the sympathetic nervous system, increases our heart rate. Fine. Next one is sharp increase in heart rate due to an increase in carbon dioxide. If you've put chemoreceptors detect an increase in carbon dioxide, which increases our heart rate even more, perfect. Absolutely brilliant. There's your answer for that one. Right, okay, so redirection or redistribution of blood flow. This one is where we're going to be using our memory method. Now, 6 marks this is worth, and this wasn't in the January exam, so this could well be in the exam that you're going to be taking on Monday. So it's really important you understand this memory method we're going to use and you actually understand this question. Garcia has been taking part in basketball training for over 6 months. In this time, Garcia's resting heart rate has dropped from 78 beats per minute to 70 beats per minute. The graph shows the percentage distribution of Garcia's blood when he is at rest compared to when he's playing basketball. Using the graph, analyse why the distribution of blood changes when playing basketball. We need to remember now that, we've said it before, when we start to exercise, our blood vessels vasodilate at the kind of working muscles because the working muscles need more oxygen, they need to remove more carbon dioxide. The blood vessels that are around our vital organs, they vasoconstrict because they don't need a blood supply. They don't need that much oxygen when we're playing sport or doing activity. Our muscles are the one that need them. Now, the memory method you're going to use to remember this, which will get you all the information, all the answers you need, is going to be, we have to look at redistribution. Okay, that's the word that is key during this. Using the graph, analyse why the distribution of blood changes when playing basketball. This is the question here. This gives you a bit of a scenario, but in reality, this little bit here, it's there to confuse you. Like, you don't need to know that his heart rate's dropped. Well done. This is showing the percentage distribution of Garcia's blood. This is what we're interested in. Using the graph, analyse why the distribution of blood changes when playing basketball. What we're going to do is we're going to get that term distribution. It may be called redistribution in another exam. Let's hope it's redistribution, because this is how we're going to get our memory method. Okay, so you're going to get the word distribution or redistribution. You're going to change it from redistribution to revasdistribution. Now, the part that we're interested in is the one in red, because that is going to give you your answer. Okay, so again, it's all to do with vasodilation, vasoconstriction. So where are we going to go from here? Using a graph, analyse why the distribution of blood changes when playing basketball. Redistribution turns into revasdistribution, and we're only interested in the red, as I've just said. What happens is the receptors, which receptors? Chemoreceptors. Chemoreceptors detect, because you're analysing it. So what happens when he's playing basketball? The chemoreceptors detect an increase in carbon dioxide. This sends a message to the vasomotor control centre, which causes a vascular shunt. The vascular shunt is when your blood vessels vasodilate at your muscles. Okay, it's called a vascular shunt mechanism. So this vascular shunt causes vasodilation of the arteries, which means we're going to supply the tissue, i.e. the muscle, with more blood. Okay, so what happens to the distribution of blood? What actually happens is we start to exercise. Chemoreceptors detect an increase in carbon dioxide. They send a message to the brain, to the vasomotor control centre, saying, right, okay, we're exercising. We need to have the vascular shunt happening. So what happens is our blood vessels at our muscles vasodilate. The blood vessels at our vital organs, they vasoconstrict. This means that more blood flow is supplying the working muscles, which means we're getting more carbon dioxide to the working muscles, which means we're getting rid of more carbon dioxide, which is going to have a positive effect on performance because you're going to be able to perform for a longer period of time. Now here it is actually written properly. So receptors, chemoreceptors, detect an increase in carbon dioxide. This enters a vasomotor control centre, VCC you could call it, which is responsible for vascular shunt. The VCC, vasomotor control centre, stimulates vasodilation of the arteries or arterioles, supplying the blood to the working muscle. You do not have to use this, okay? This is a brilliant way to remember it, but if you can think, okay, redistribution, it's about vasodilation, vasoconstriction. Perfect. If you can do that, that's what we want you to talk about with regards to this screencast, okay? Right guys, so that is it with regards to the responses. Remember, you've got the cardiovascular as opposed to vascular, which is going to help you detect the responses. Then you've got anticipatory rise, the increase in heart rate, that's because of carbon dioxide. And then you've also got the redirection of blood flow, redistribution, revasdistribution. So hopefully that will help you, and I'm going to just about to do a screencast on the adaptations, and then we can really get cracking with this. Okay, thank you. Bye.